So in last class, what we have ended up with is trying to learn the basic fundamental of electrical principle that will be required, and we have not covered much. Then Ohm's law, we have discussed about the Ohm's law. If you cannot hear me, just let me know. Then we have discussed about the KVL and KCL. So we end up from this point, and I have told you that we will discuss today about DC and AC. This is important to know what is the difference between DC and AC. I know all of you know these things, but I want to just review this thing before I am moving to this topic. Okay? What you are trying to tell him? Something interesting? Okay, so what we will do is DC and AC. So what is the difference between DC and AC? If I tell you, ask you, as an electrical engineer, we should know, we should understand, and we should be able to explain what is DC. DC is elaboration is direct current that we have discussed in the last class, right? And I think you have already learned this one, direct current. And AC is alternating current. Now, what is the difference between DC and AC? By the way, we have discussed about three main quantity in electrical engineering. What are the quantity? We have discussed, we have introduced in the last class. Three main quantity. Voltage, very good. Voltage, current, and resistance. Okay. And whenever I have told you that this is direct DC, that means DC can be of voltage and DC can be of current. And similarly, AC can also be voltage and the current. Now, what is the difference between these two quantities? What is the graphical representation? How can I represent graphically DC? And how can I express DC in equation mathematically? So we need to know both the thing. We need to understand the graphical representation as well as mathematical representation. Mathematical representation for analysis and graphical representation to understand how the DC look like. Okay. So if I tell you the graphical representation, what would be look like? So how do we represent the electrical quantity graphically? What is the common way of representing graphical representation? We do different way. One of the very fundamental ways.
Okay, plotting it like voltage against time.
Yeah, so this is a special name. Yeah, you are right. So we are plotting against voltage or the current against time, right? And what is this name? If we plot this one, this has a special name. What is that called? All of you know this thing. Whenever I plot electrical quantity against time, that has a special name. What is that name? All of you know, I know. No, this is called the waveform. All of you know, right? This is called the waveform, representing any quantity against time or the angle. Now, if I compare, if I draw this one, this graphical representation, what it look like? Let's say I have a DC voltage, VDC of 5 volt. And I have an AC voltage of sinusoidal representation, it will be say 5 sine of theta. Okay. So AC, usually we use sinusoidal, right? This is because we are generating signal in a sinusoidal form. So that's why we are representing in sinusoidal. So sinusoidal is the fundamental AC signal, but we can have variation in different ways. Square wave, we can have trigonometrical, but our supply is always sinusoidal, and we prefer to be sinusoidal. Whenever we are generating from the generator, naturally it is producing a sinusoidal signal. So that's why we express as a sinusoidal. But it can be other form, but that is usually is not pure alternating voltage. Okay, it's a combination of sinusoidal signal. Now, if I draw these two waveform, what would they look like? Any idea? Have any idea? DC?
But this would be a straight line.
Is a straight line, and this magnitude is 5 volt, right? AC will be sine wave. And this one we can write, this is instead of T, this one is theta, we can write as a theta, then this will be equal to 90 degree, this is 0 degree, and this one would be 180, this one would be 270, and this one will be 360, and this will be repeating in this way, right? Now, usually we don't express in terms of theta. What we do, we write down this one as sine of omega t. This omega is the angular velocity. Okay, and this is sometimes is written as twice pi f. Pi is constant, f is the frequency of this signal. So f is the frequency of this signal. So if you translate this one, let's say for our case in power system, what is the frequency? 50 hertz. So we will translate to 50 hertz. And then I will have this one would be equal to 2 times 3.14 times 50. That will be 340. That means my sinusoidal signal I can write down as, so this is B is a function of T that can be written as 5314T, right? All right? Understand? So I can express my sinusoidal signal. Now let us come back to this one. Now what is the difference, graphical difference? What you can find out? What is the difference do we have here? One is how it is linear. What is the definition of linear? Constant. It's not linear. Linear means it's varying with time. Okay. So it's a constant value. So this one is constant value. What about the polarity? Doesn't change. What do you mean by polarity? Plus and minus. So yesterday we have discussed, right? What is the meaning of the polarity? Let's say I have connected a voltage, the source, and I have a resistance. So polarity of this voltage, I am considering current is moving in this direction. Whenever I have the current moving in this direction, then this is plus and this is minus, right? So it indicates the direction of the current. Polarity indicates the direction of the current, right? Now, if I change this connection, slightly change this connection with negative and then positive, then my polarity is changing, right? I have minus here and plus here. Okay? Is that correct? So that means for DC, whenever I am considering DC from a source, it is always polarity will remain same. As long as you are not changing this connection, you are not changing this connection here, you don't change the polarity here, your current will flow in the same direction. Okay? For a DC, it will be same directed current. That's why it's DC, direct current. It's only one directional current. As long as your supply is not changed, it will remain constant. Right? Now here in the alternating, so that means here 5 volt is always 5 volt, here positive 5 volt. With time, it doesn't change. But here, if you take a look on the right hand side, what I have during this half cycle, let us take a different color. During this half cycle, what I have? What is this property of this half cycle? Is positive. It remains always positive, right? During this part is positive. And during this part, sorry, let us take this is red. So this part, I have the negative value. Okay? That means if you connect the same source, let's say I have connected a voltage source here, and this is not a DC, this is an alternating, right? So we know the symbol, right? So this is an alternating current, producing an alternating current. Now, if I tell you what is the polarity of the voltage across this resistor? So I have voltage here across this resistor. What is the polarity? Which one is positive? Top one or the bottom one? Top one or the bottom one? Top one. Now take a look of my sinusoidal signal. So this one is producing a sinusoidal signal like this one. Right? So we have discussed that this will be the positive and this will be the negative. Now, whenever we have supplying this part, because same generator is producing, is continuously changing, right? Sometimes it becomes positive, sometimes it becomes negative. So whenever we have positive this part, the polarity is here, positive, and here is the negative, right? So due to this one, compare with the battery, we'll have the current flow in this direction, right? So I will have the positive polarity here and negative here. That's all right. You are correct. Right? Now, let's say it is with time, it is moving. So it has started from 0. If it is a 50 Hz, this will be 10 millisecond and this will be 20 millisecond. So after 10 millisecond, what will happen? This starts going to the negative. Right? So whenever it is going to the negative, then what will happen to this one? That means with respect to this one, this has just reversed the direction, right? Now this polarity is no longer positive, it becomes negative polarity. And it becomes positive polarity, right? So that means now my current is flowing in the upward direction. So it is moving in this direction, coming back here. Right? So that means you are correct, but half correct, not the full correct. Because half of the cycle it is supplying in one direction and half of the cycle it is supplying in the other direction. Now question is why I can see? Because sometimes it becomes 0, there is no current is flowing, but we cannot see. Why we cannot see? Yes, it is too fast, changing is too fast that you cannot. We don't have the ability to see these changes, but it is continuously changing. Okay, so this is the first thing we have understand that the AC is continuously changing the direction. The current flow is continuously changes in my circuit. That doesn't change with DC. Okay. Now, this has a serious impact whenever we do analysis. Okay. Let us take a look that I will add to DC that is having two different magnitude. Let's say in the same time, up to 20 millisecond, I have a DC of 5 volt here. This one is 5 volt. And I have another waveform that I can draw, that is time in the same 20 millisecond. I'm giving just an example. And I have another waveform that is of, let's say, 7 volt. Now, if I ask you to add these two waveforms, what the waveform look like? The resultant waveform. I want to add this resultant waveform. What would be the waveform look like? It would be 12 volt. Very good. So we can just easily add these and tell, okay, up to 20 is 5 for this one and 7 for this one. So that would be 12 volt up to this one. So it would be 12 volt. It's easy, right? Now let us do the same thing for the AC. I will take a look of the AC. I will take the same AC that is of 20 millisecond is the period. That means I will have positive cycle here and negative cycle here. And it has maximum value of 315 or 314 and maximum value of 315 here. Okay. Now I have another waveform of 20 millisecond, same period, but this one is say this is 200 and this is minus 200. Let's take a round figure instead of arising difficulty. So this is positive and this is negative. Now I want to add these two. As I have done with the DC, I want to add these two. What would be look like? So what is the process? How we will do that? We will take some sample points, okay? Instead of doing every point, we will take some sample points. So what we will do, we will start with the sample point from here. Let's say we will take this point and this point. So each of the corresponding point, we will add the value. So then we will take this value and this value. And then I can take this value and this value because it's the same frequency. I'm considering same frequency signal. And then I will take this one and this one and this one and this one. Now if we add these, what would be the value look like? So at 0, both of them are having 0, right? So I will draw here same point 20 that can be divided into four different sections, right? So we can take this one is the 10 and this is 5 and this is 15 millisecond. So we'll take the same one here. This will be 5, this is 10 and this is 15 millisecond. Now if I add them, then here it will be, if you take a look, it will be 0 and 0. That will give you 0 value. Now at 5 millisecond, I have here 200 and here 300. So I will add them together because they are all positive, right? So I don't have any problem. So I will add them together. That will become equal to 500. And then I have 0 again. that will become 0, and then here I will have negative 500 minus 500. Okay. So then I can add these numbers and it will be look like this one. Okay. Up to this, is this clear? Is this clear? Now this look like the similar, right? With the DC and AC, there is no problem. I am just adding the numbers. Right? Now, if I just slightly change this signal, let's say, is there any question up to this? So I am starting with the sinusoidal signal at T, and I have started with 20 millisecond, and this is 10 millisecond, and this is 5 millisecond, and this one is, say, 15, right? So this was my initial voltage was like this one, and I have considered this is 300, right? And this peak was minus 300. Now what we want to do, so this, what is the equation for this one? So this is VT. What would be the equation for this one? We have discussed this one. What is the equation? Is 50 Hertz. So this is coming from here, right? 5314T. Because we are taking, when we have taken 20 millisecond is the duration for one cycle, that means it's 50 Hertz. So I can write this equation. If you write this equation, what would be the equation? 300 is the maximum value that I have to plug here. And then it will be multiplied with sine of 2 pi f instead of f. What we can write down? 1 over 20 millisecond, that will give me 50. You are correct. So, okay. So 20 millisecond, that will give me frequency of 50 Hertz. Okay. At 2 pi f and then multiplied with t. So this will definitely give me the same as 300 sine of 314T, same as that one we have got in the previous. So this is why I have written this one. T is equal to 20 millisecond and F is equal to 1 over 20 millisecond. Okay. All right. Is this clear up to this? Now I want to change this sinusoidal signal slightly, and you need to tell me what would be this equation. So what I am doing, I am changing this sinusoidal signal. Everything is same. So this is 300. Instead of starting from 0, it has started from here, and we know this angle. Let's say this is 90 degree, minus 90 degree. And this is, I'm giving angle because to make it simplify. And this is my time. So I have everything same. And instead of this one, now it has changed to this one as 20 millisecond. That means starting from this peak, it is going to this peak, and this is the period of this signal. I have the maximum value of 300 and minimum value of minus 300. Now, can you tell me what is the equation for this one? This and the previous one are the similar, but has been shifted a bit. I cannot make it. So if I draw it again, so my original signal was original sinusoidal, sorry. This one was not the original. So original sinusoidal signal was this one. No, I will use sine. I don't want to use cos. So this one is 20 millisecond. and this is 300. Same, everything is same. So this is 20 millisecond. And this has started from this point, but here this point has been shifted towards this one. Now I want to express this. I know this equation. This equation I have already given to you. Vt is equal to, what is the value I have given? 300, right? 300 sine of 314t. So this is my equation. This is the fundamental sinusoidal equation. And at t equal to 0, sine value will be 0. T equal to 5, sine value will be maximum. T equal to 10, sine value will be 0. T equal to 15, sine value will be negative maximum. This is usual sinusoidal signal behavior. And this is following. This equation is given by this one. Now, what would be the equation on the top?
Can we get that in two portions?
What do you mean by two portions?
The portion before the 0 and after the 0.
No, this is the one wave, so there will be one equation, right?
We just subtract the angle.
Subtract the angle. Yeah. So we will not subtract the angle. So this will be the same sinusoidal signal. I can just write down here that this is my same sinusoidal signal. So definitely these things remain same. So everything is same. So I will just write down this one would be 314t. Up to this, there is no problem. Now, in previous case here, if I plug here 0, then sine of 0 becomes 0, and that's why we are getting 0. But here, what we are getting maximum. That means we are no longer here. At t equal to 0, we have started from here. Okay? That means it is getting 0 earlier. Alright? So I have to somehow tell my equation that it is 0 is not at 0, it has been shifted to the left. So how can I do that? How can I tell? This is a language, right? Mathematics is a language. Instead of writing that it has shifted to the left, I have to express mathematically. How can I express mathematically that it has shifted to the left? Where it is getting 0? Where? We have to find out where it is getting 0. At t equal to minus, that means this becomes, so I have given, this might be confusing you. This is 90 degree and this is t. And we have to remember that omega t is equal to theta. Okay? So let us just write down the same equation in terms of theta. Okay, so if that is the case, then we will be able to identify what is the value. So what was the equation? Instead of t, I will write down, instead of t, I will write down theta. And then this whole part, I will replace with a theta. So it will be 300 plus, 300 sine of theta. Okay? Now, theta equal to 0, it should get 0. That is the criteria of the sinusoidal signal. But it has get 0 at some point earlier. So, we need to consider that one where it has got 0. So where it has got 0 at theta equal to minus 90. If you take a look here, I have mentioned this is minus 90. That means here it is positive and here it is negative. At theta equal to minus 90, it becomes equal to 0. So if you want to make it 0, what do you have to do? You have to add here 90 degree. So in that case, what will happen if theta becomes equal to minus 90, that this whole equation inside the sinusoidal will become minus 90 plus 90 would become equal to 0. Then I will have this 0 available, right? So that means I have to add some extra angle with this one. Okay? That angle, whether it will be positive or negative, that depends on from where it has started. 0 has started. Now, if I shift my sinusoidal signal to the right, that means I will have some value here. It has shifted, say, at an angle of alpha to the right. Okay? So if this is the case of the sinusoidal signal, then my sinusoidal equation will be equal to B theta would be equal to sine of, 300 that I missed. So I need to write down this is 300 and sine. Now this theta will be as it is. Now I have to think where it will become 0, in which direction it has moved, to the right. And at which point it is my reference 0 has moved, at theta equal to alpha, right? If theta equal to positive alpha, at that point I have to make it 0. So that means if this one becomes alpha, I have to subtract this one to make it 0, right? So this becomes positive alpha. So what I have to do? I have to subtract negative alpha. So that means with this one, I have to add a negative alpha so that it becomes positive. It becomes 0. Clear? Yes or no? So if I move to the right, that means at some positive value of theta, it becomes 0, right? So that has to be subtracted. If I move to the left from the origin, that means some value of negative theta, it becomes 0. So that has to be added. Okay? So this additional angle that I have added has a name. What is that name? What is that name? So my generalized expression for sine theta, if I express now in terms of t, generalized for any sinusoidal signal. For any sinusoidal signal, I can write down expression as A is the amplitude, sine 2 pi, F is the frequency, and then multiplied by T. So 2 pi is constant, no variation, it will remain always constant. F for New Zealand power system, this is fixed. If you go to India, it's 50. If you go to America, it is 60. So F, sometimes it varies, but for a particular country, if you consider power, it will remain constant. Then time is the variable that will vary. Now we can have added another term that is called theta. Okay, this is the generalized expression. It can be plus or minus depending on in which direction it has shifted. Okay, and this one is called, what is the name of this one? It's called phase angle. Very good. So this is the phase angle. Okay. Now, interesting point we have come whenever we have understood that we need to express a sinusoidal signal. See, now what did we need to express a sinusoidal signal? When I have told you that this is the generalized expression of a sinusoidal signal, what are the quantities you need to express? What are the different quantities you need? Do you understand? If you don't understand, tell me. So whenever we have given the expression of a DC, we write usually a capital letter. So we have given the expression by 5. We don't need anything, right? If I just write down V DC equal to 5, everybody will understand that it has always started from 0 and continues infinite time and remain constant 5 volt. Okay? Now, whenever it's alternating current, can we do that? We need more terms, right? More information. What are those information? What are those information? If I take a look here, this one, let us just take a different color. What is the information I need? I need to tell what is the maximum value you are talking about. You are talking a sinusoidal signal. Now, what is the maximum value of that sinusoidal signal? That I need to tell. This is the magnitude. I need to tell the audience that this is the magnitude of the sinusoidal signal I am talking about. Because if you change the sinusoidal signal, the shape will be changing, right? If it is a 230 volt, it will be maximum will be 230. 230 RMS value is different. We are not talking about its peak value. 300 peak value, that means maximum value will be 300. And if it is 200, then maximum value will be 200. So A, depending on A, your size of the sinusoidal will be changing. Now what else? This one we have mentioned, this is constant. This has no effect in my sinusoidal signal. No change in the sinusoidal signal. This frequency, will it affect my change of the sinusoidal signal? Frequency, if frequency change, will it change the sinusoidal signal? How does it look like? Yes. If you make it 100 hertz, we have considered 50 hertz signal, right? We have considered 50 hertz signal, and we have calculated that if 50 hertz, the period will be 20 millisecond. I'm not sure. Is 50 is 20 millisecond, right? Yeah. So long back I have calculated. So this is 10 millisecond is the midpoint. Then we can take half of this one, and my sinusoidal signal will be look like this one. That means at midpoint of half cycle, it will be peak, and then it will be. Now this is 50 hertz. Okay, F equal to 50 hertz. That means I can find out T equal to 1 over 50. That will be equal to 0.2 second, 0.2 or 2.02. 02, right? So 02 second, and then I can take this one 20 millisecond. Okay, that's how we have calculated. Now let us take a look of frequency I will double. If I take frequency of 100 hertz, then what would be the period? So 100 hertz, and then T would be equal to 1 over 100. So that means this will be half, right? So that means it will be 0.01 second, and that will be 10 millisecond, right? Now that means my signal, I will keep this one as 20, but my signal now, the period of this signal is 10 only. That means I need to divide this one as 5, and then 2.5, and this one 2.5. Then my signal will be look like this one. And then it will be changing, it will be repeating here. Okay? So what is the difference between this one and this one? So previous one was looking like, so I had 20 and 10, 5, 15. So previous signal was looking like this one. Was there change? Yes, that has changed. And in 20 millisecond, I have now two similar sinusoidal signals. So that means this frequency has an effect in my signal. So this is another property of my sinusoidal signal. So this frequency has another property. Okay? Now the third property is this phase shift. So phase shift is the third property. Now, if you don't change this frequency, say for power engineering, we are not changing the frequency, right? Then this part has no impact in my sinusoidal signal because you are not changing this frequency. But this phase can be changed. And if phase is changing, that two signal will not be the same. Say, I have drawn this signal, two signal, say this one. Do you think the first one and the second one are the same? I don't want this one. Okay, so here I have shown two signal with the same duration, same period, same amplitude. But do you think this one and this one are the same signal? No. We can verify this one, they are not same. So if you, that means if its frequency is same, then also the phase has different value, and that has to be considered whenever you do the calculation. So that's why whenever you have added this sinusoidal signal, DC signal, you didn't need to consider anything angle. Only the magnitude was enough, right? But here you need to consider this angle. Okay. Now, if we add these two, how we can verify that this angle is important? How can we verify that this angle is important? Anybody has any idea how we can verify that this is not important, but we need to, if we understand that one. Now, what we can do, try to draw one of these signal and two signal of the same amplitude, same everything, then add them together, that we have done in the previous case. And then you add these two. First add these two signal are there. So can you add these two? These two signal, can you add them? Following the same procedure that we have done. We don't want to do mathematical, the graphical. From the graphical representation, I want to add these two signal. What would be the addition? You can do that, draw and try to do add these two signal. Okay. All of you have signed your name here? Who is missing from the last class? Is Rishabh and Rajesh and who else? Mandeep is not here anymore. So he has moved to the other class. Ovishek, who is Ovishek? Is there anybody here? Ovishek? No. Abhishek was here yesterday, last class. Can you just write down here his student number and name? Okay, write down the name. I will find out. And also you, Sarman, can you write down Rishabh, last class? Anybody else who is missed out in the last class? You were not there in the last class, right? Were you there in the last class? No. Yeah. Last class? No. I have uploaded the recording from the distance learning. Last class we didn't record it. Yeah, very basic thing. We copied this one, then I can close the sharing from here. I will move to here. Did you get it?
Yeah. I think I got it.
No? All right, if you don't get it. Okay, just show you from here on MATLAB. Some of you have done the MATLAB. So just, you don't need this one just to understand, okay? So what we want to do, I want to add these two signals. One is V1 and I have given 300 is the amplitude multiplied by sine. Then this is the value. So T I have taken, I can take the one cycle. So then it will be 20. So from 0 to 20 millisecond I have considered, and then I have multiplied 20 to the power minus 3 to indicate this is a millisecond, okay? So this is my sinusoidal signal, original sinusoidal signal having no phase shift, okay? And this is my shifted one. And now I want to add here. So V would be equal to V1 plus V2. Okay. And then I want to draw here the last one. All these three I want to draw on the same figure. So this one will be V. Okay, let us try to simulate. I'm not sure what it will produce. V1, oh, it should be V2 here, right? Missed out. And then this one is fine now. Now, we can easily identify which one is V1. So this is my V1, right? So this has started from 0, continues. This is up to 20 millisecond. Okay? This is up to 20 millisecond. And this has started from 0, and then it has continued and end at 20. But this one is starting, maximum is here. That means it is the shifted one that has been shifted to the left. If you remember, I have no drawing there. So that one is shifted, that is given by 90-degree phase shift. Now, if we add them together, that means each of these points has been added together. And then you can find out your maximum has shifted here. I can assume this is my maximum point. Where it has shifted around 3 point something, right? And this maximum has shifted here. So that means it is not following the maximum of any of these two signals. It is finding somewhere different. Is that clear? Now, if you have not shifted this one, so this is the angle shift. One of the signal has been shifted. Now, if we have not shifted this signal, what would be the look like that we can take a look? So if we just remember this one, then we can just take a look at, we have just modified this one. This shift we want to remove from here. Now these two signal become same, V1 and V2. Now if you plot it, you can find out that it is holding. So this is my new one. Both of them are having the same. Okay. So let us just remove that figure, redraw this figure, otherwise it will be confusing. So redraw this one. So now you can see here, this is my signal look like. Now you can see what we have three signal, but two of them are the same value. And you can see the resultant figure is following my original signal. So peak is at maximum, wherever the maximum was the original, peak was there. But whenever this one is negative maximum, this resultant was also same at same point. But whenever we are shifting the signal, that resultant is not following any one of the original signal, it is coming up with a different position. So that means whenever you shift and do some kind of addition or subtraction, then that shift has an impact on that addition or the subtraction. What is the conclusion we can make from here? What is the conclusion we can make here? So whenever we do any kind of mathematical operation with the sinusoidal signal, we cannot do it only with the magnitude. We have to consider the angle. Okay? So if I just consider that magnitude is 300, that is true for this one, that if I know this 300 is the magnitude, then I can just add them. But if I shift it, it is a different signal and we have to consider that one. So that's why whenever we are talking about DC, is easier. We are just considering only one magnitude. That is the property of a DC. But whenever we are dealing with AC, it is not, the characteristic is not dependent on one quantity. It depends on other two quantity, frequency and the phase angle. Right? Do you get the idea? So all this discussion is, the conclusion is here. So whenever we consider the DC, DC has only one characteristics. You can explain DC with only the magnitude, because if you change, you cannot change any other quantity. If you change magnitude, that DC will be changing. 10 volt and 5 volt is not the same. But that phase angle has nothing to do with AC, DC. But whenever is AC, you have how many characteristics do we have for AC? Actually 3, but for the power system, it is always frequency same. So 2 other properties. One is magnitude, another is the phase angle. So if somebody asks you what are the properties, characteristics of a sinusoidal signal, definitely changing the direction is the physical properties, and mathematically representation, it needs 3 different characteristics. Magnitude. Whenever magnitude, we talk about the amplitude, that means maximum value or peak value. Okay? Then frequency and the phase angle. Clear? 3 characteristics sinusoidal signal has. And for the power system, sinusoidal in the power system, frequency is always constant. So 2 properties. One is magnitude, another is phase angle, right? Now that means I cannot, in order to express mathematically, if I want to express mathematically, I will share it again, then we need to discuss. All right. So if I express mathematically, so I need to stop sharing from here, and probably I can share from here. Which one is anything? Okay, so in order to represent a sinusoidal signal, we need two quantities. So representation of a sinusoid, make it change, man. Let us try. What's the time? Yes, we have enough time. So in order to represent sinusoid, change. It's not changing. So in order to represent sinusoid, mathematical representation. So mathematical representation. So in order to mathematically represent, I need two quantity. This is similar to a vector, magnitude and the direction. So the way we used to represent a sinusoidal signal, we can represent in two ways. One is called the polar representation. Polar representation. So in polar representation, I have a sinusoidal signal. Let's take the previous example. My drawing is not accurate, but you can assume this is my sinusoidal signal. This is 20 millihertz. We will take the same example. And this sinusoidal signal, I can represent Vt is equal to 300 sine of 314t. Okay. To generalize this one, we can just write down A sine omega t plus theta. Okay. So this is my sinusoidal signal. Now, mathematically, we don't always write this expression. Instead, we write in a polar form for doing our mathematical analysis, because that makes our life easy. We don't want to do addition of sinusoidal signal all the time, because this one involves trigonometrical operation, but we don't want to do that. Instead, we want to do the same thing in different way. What we do, instead of representing with this expression, what we do, we write down as a capital letter and with a vector sign. Okay? Then as we have discussed, there are two important quantity that has to be used to represent this vector. So this vector now will have the amplitude that has to be considered. Somewhere it has to be there, but we don't use this amplitude directly, maximum value. What we use? The RMS value. How to represent? Find out the RMS value. What is the relation between peak value and RMS value? We have all learned this one, right? So what is the peak value? So if Vp is the peak value, and V is the RMS value, then what is the relation? What is the relation between V and Vp?
V equals Vp divided by root 2.
Vp divided by root 2. Okay. So that what we are using for the vector representation, A divided by root 2. Okay. So this is one of the quantity that was required to represent a sinusoidal signal. Instead of peak value, I am taking the RMS value. Clear? Now another thing I need, because this quantity from one sinusoidal to another sinusoidal, this is varying with frequency, but for power system, it all the frequencies same. So this quantity we will ignore, that there is no variation for this one. Then the next one is this angle that we need to consider. So that angle we place here as theta. Right? Now the same signal that we have represented before, Vt was 300 and sine of 314t plus pi by 2 or 90 degree, right? That was the signal. Now if I want to represent in polar form, what would be the polar form? This is V, and then what I have to do, this 300 is the peak value, has to be divided by √2, and then I will make an angle of pi by 2. Now these two expression is same, synonymous. I can use any of them. So if I write down this expression, you should be able to write from this expression, this one you should be able to write. Okay? And if I write down this one, then you should be able to write this one. This is called the polar representation. If I write down generalized polar representation of current or voltage, polar representation of current, that would be equal to, what would be the polar representation? This is my vector or phasor, and then it would be I RMS and making an angle of theta. What is the theta? Okay. Now if I draw this one, what would be the phasor look like? I can draw it in the coordinate system. What would be the coordinate system if I draw it? Let's say this one was my sinusoidal signal. Can you draw it in the coordinate system? 300 divided by, all of you try to draw this one in the coordinate system. What would be look like? This is my vector. I can write down here V. We have found 300 divided by √2, making an angle of pi by 2. Can you draw in the coordinate system? All of you.
Draw this one in the coordinate system. This is the polar representation, and it should be a graphical representation for this one. What is the graphical representation of this one? How I can draw this graphical representation? This is a mathematical expression. How can I use the graphical representation? Done? Yep. Yeah. All right. Graphical representation of this polar form.
Wasn't sure if you
Looking for this one. This is a language that everybody understands.
Okay. Yeah.
Mathematics is also a language.
Mm.
It's like an English and other languages. Mathematics is also a language.
Absolutely. That's it.
So how to represent the polar in a graphical form? We have to find out. Are you trying? Should I wait? Should I wait or
Wait.
wait?
All right.
All right.
So we need to find out this value. Let us consider this magnitude. I don't want to calculate, just we want to know how to do that. So what I need to do, we first need to understand what is positive angle, how do I measure positive angle and the negative angle. So if you take a look of the coordinate system, this I will take x-axis as my reference. So that means it is making an angle of 0 degree. Then positive angle means I have to go counterclockwise. So my plus 90 means I have to move in this direction to plus 90. This is the angle. And then this is the magnitude I have to measure from 0 to this direction of this magnitude. So that means 300 divided by root 2. This should be proportional. This length should be proportional to this magnitude. This is the graphical representation of polar vectors. Vector in polar can be represented in this graphical representation. Now this one, as I have mentioned, all this I have derived from the sinusoidal signal. So this also indicates a sinusoidal signal. So you can derive the sinusoidal signal from here also. So we need to understand the relation whenever we are talking about, okay, this is a phasor of the voltage. That means this is actually a sinusoidal signal we are talking about. For simplicity of calculation, we have represented in polar form. Okay? And this polar form is look like this one. I can represent to visualize this polar. I can take a look in this way, because that will simplify. I don't want to draw sinusoidal wave and draw every point. That is more complicated. But if I have a representation like this one, that would be much easier. Say, I can show you how easy is this one. Let us take, I will take another signal of the same phase shift. Say it is 20 at an angle of plus pi by 2. This is my second vector. So what I can do, I can add this 20. If I want to add this V plus V2, then what I need to do, I need to draw these two signal on the same plane. So this is my 300 by root 2, because if the angle is same, because on the same line it will be added. So I will add another 20 from here, 20. That will be my total length will become equal to this 300 divided by root 2 plus 20. So this is my total length, and this will be the resultant vector. I can see the resultant vector will make an angle of 90 degree also. So I can, if I know this one, I don't need to draw the sinusoidal again and again. I can draw these polar form and add them. If I do the multiplication, it's the same case. We can do the same thing, right? That makes our life easier. That's why we have represented we have left the sinusoidal representation to this polar representation to make our calculation, our life easy. Otherwise, we have to do trigonometrical operation and find out the addition. That was not easy, right? If I add two sinusoidal signal and add the sinusoidal signal with sine function, that we can do. I'm not telling that we cannot, we can do, but it will be more complicated. So to make life easy, we have represented in the polar form. Okay? Now, we have learned to represent a sinusoidal signal. Let us take another example. I have a sinusoidal signal Vt is equal to, say, 50 and sine of 140 and minus 45 degree, expressed in polar form. And I have another equation, another signal, say 30 and angle of 60. So express in sinusoidal form. Sinusoidal expression. Do it quickly, then we'll move to complex number and rectangular representation. So from the top, let us make it easy. So I will add multiply with root 2 here and divide by root 2 here. That will make life easier. Express and draw. So it's not only the expression, draw. Sinusoidal, you don't need to draw. What's your name? Shubham. You're not doing.
I will know I know vectors, but I'm forgetting about it. Like to convert from like polar form to a rect.
I am not asking rectangular form. It is the sinusoidal. The rectangular is the next one. What we have discussed, it is this.
So
So
the
sinusoidal from polar, polar
polar
to sinusoidal.
So that means like negative 50 degrees will just go as it is at the angle. All right, sure. So maybe I was thinking too much.
Yeah, sometimes it happens. Okay, let us just write down. So if I have been given V equal to Vp sine of omega t plus theta, then the polar form would be equal to V vector Vp divided by root 2 and angle will be theta. Okay. If V is equal to Vp sine of omega t minus theta, then this will be V and angle Bp divided by root 2 and angle of minus theta. Okay. And if I draw this one, then it will be look like, sorry, it's okay, no problem. So if I draw this one, then this is my reference. So this positive angle will be here. So this is my Bp divided by root 2 and this angle will be theta. Now if it is negative, then this is my reference and this will be my angle. This will be minus theta is clockwise direction and this will be Bp by root 2. Okay. To summarize. Now if you have the other ways, this one. So if you have given the polar, then you have to represent this one. You have to find out the peak value from here. And then omega t will be always there. And you have to take a look, sign, angle is positive or negative. If positive, you add them. If it's negative, you subtract them. Okay? Clear? So now if you do this one, then this will be equal to 50. So V would be equal to 50 and angle will be minus 45 degree. Okay. Now, if this one you want to write down the sinusoidal, let me write down in different color. So sinusoidal, it will be Vt is equal to 30 and then sine of, we will consider 314. If the frequency is not mentioned, it will be 50. So this will be 3140 plus, why plus? Because here is a plus and then this is my 60 degree. Okay. Clear? Okay. So this is the summary of the representation. If you have an expression, then you can convert it to polar form and rectangular form. Any question up to this? Then we'll move to our next topic. And today we want to finish every fundamental thing. Then from next class, we'll start with actual topic. Smaller means you want to take a look of this one. I'll upload this one. You don't need to copy this one. Okay. So this is the representation. Now, I have mentioned why we are coming to polar form. Sinusoidal is much better whenever you want to see the actual happening. But we have moved to the polar form to make our life easy to do the calculation, right? So if you have two vector, let's say I am representing one vector is making an angle of 45 and this angle 33 is amplitude. But another vector is making an angle of, I will take a different angle. So let us take another vector is making an angle of, say, 60, and this is also 3. Now, I have told you previous example, I have given that two vectors having same angle, you just add them together. Now, these two, if you want to add, we all understand this is sinusoidal signal is represented in polar form, but you need to do addition. What you will do, how you will do this?
Well, okay, we add the trees and multiply the angles.
And the square of them and
Uh,
take out.
we multiply the we multiply the trees and add the angles.
Multiply the trees and add the angle. Is that correct? What you do?
Addition. I will convert them to rectangular form.
Can we do the addition in this form?
No. In polar form we can't.
We
But
can't.
you have to
Okay.
convert them to rectangular form.
So we can't add them because they are two vectors having two different angles. If they were same angle, then we can just add them together because in the same direction. Okay? But they are not in the same direction. So they are not the same. They are not representing same sinusoidal signal. One is making an angle of 45 degree. That means shifted only quarter cycle. The another one has shifted more than quarter cycle. So you cannot add them these two different sinusoidal signal. So what we need to do, is this clear? So if you draw the sinusoidal signal from here, then it will be look like one would be look like, say 45, this is 90, 45 would be somewhere here and your peak will be somewhere here. So it will be 45 degree. Okay. And then this one, if I draw this one, this will be 45 here and then 60 here. And then it will be 90 somewhere here, very close. So it would be something like this one, this peak here. And then it will be this one. So two are two different sinusoidal signal. One is making an angle of 45 degree. That means your 90 degrees somewhere here, far away is half through another 45 degree angle it is making from 0. Okay, but here it is coming closer. Okay, because 60 plus 30. So closer. So two different sinusoidal signals. So you cannot add them directly. This magnitude cannot be added. So that's why what we need to do, if you have a polar representation, if you know this polar representation, and then let's say this is amplitude and this is the angle, or this is V and this is the angle. So I can represent this vector as a V angle of theta. So what we do, we represent, we make the fraction of this vector in two parts. One is the horizontal part, let's say Vx, and another is the vertical part, and this is called Vy. Now, what is the value of the horizontal part? Vx would be equal to trigonometrical formula. So this is my angle, theta. So I can write down cos theta is equal to Vx divided by V, right? So cos theta is the base divided by hypotenuse, right? So I can write down from here Vx equal to V cos of theta. Similarly, Vy I can write is equal to V of sine of theta. Okay? So that means I can represent this one as one of the quantity in horizontal direction, another quantity in the vertical direction. And this is called the rectangular form because I have made two components of the vector. Now, if I make, what is the benefit? Now, if I take a look of two components, one would be in this direction, another would be in this vertical direction. And one would be in this direction, another would be vertical direction. Now, if you take a look, this is the equivalent, right? So this will be equivalent. One is in this direction, another is in this direction. Now, this one is also in the y direction, and this is also in the y direction, right? So both of them are in the same direction, so you can directly add them together. And this is also in the horizontal direction, in the same direction, same axis, so you can add them. Previously, we cannot add these two because they are two different angles it was making. But now this red one, when I have made two components, now this red one is making the same angle of 90 degrees, right? So I have two components, so similar component I can add them together, right? So this one and this one I can add them together. So my resultant, I can find out, okay, resultant will be this one. Let's say this one would be, what I will say, this is a B, Y, and this is Bx. And this is my B vector. And this is my A vector. And this is AY. And this is AX. Okay. Now this AY and BY is making an angle of 90 degrees with my reference. Both with the same reference is making the same angle. So I can add them together, AY plus BY. And in the same way, I can add AX and plus BX. Okay? If you know AX and BX, then you can find out the resultant. How do you find out the resultant? Using the Pythagoras equation, right? We have found AX plus BX and AY plus BY. Now, if you know this one, you extend rectangle and then add them together. This will be your resultant C. Okay, you know this one, you know this one, then you can find out this new angle of theta for C. So what would be C? C would be equal to root over AX plus BX square plus AY plus BY square. And this angle I can use tan to find out this angle. Tan inverse AY plus BY AX plus BX. Right? Right? So this representation is called the rectangular representation because it is representing two lengths of a rectangle. So that's why it is called the rectangular representation. Okay? So I can write down this one. So AX, I can write down equal to A is a vector making an angle of theta that can be written as A cos of theta plus A sine of theta, right? A cos of theta plus A sine of theta. That's what we have done, right? This is one way of representing the rectangular form. This is actually AX and this is AY, right? Now at the end, this is a number, this is a number. We have to distinguish which one. If you write down, say, you have found that 5 an angle of 60 degree or 1 as an angle of 60 degree. Okay, this is my polar form of vector. So what I can write down, I can find out A cos theta is equal to 1 cos theta cos of 60 degrees is root 3 by 2, right? Okay, sine of 60, sine of 60 is root 3 by 2. And cos of 60 is half, right? Cos of 60, cos 30 equal to half, cos 60 is root 3 by 2. 60 root 3 by 2. You are even confused than me. Or sine. What I have remembered is sine. Sine 60 is half. So yeah, this should be reversed. This should be half. Here it will be half because I have remembered the sine one. Sine 0 is 0. Sine 30 is half. Sine 60 is root 3 by 2. Sine 60 is root 3 by 2. And this will be half. Okay? So if I find out the two fraction, A1 sine 60, then I will find out half and root 3 by 2. Now if I write down this way, that this is equal to this one, do you understand? Which one is sine part, which one is the cos part? If you write in this way, I can identify, okay, this part is sine part and this is the cos part. But if you write down in numbers, can you identify which one is the sine part and which one is the cos part? These are two numbers, right? So we cannot do identification. So in order to make it identifiable, we represent this rectangular form in a complex number. What is the complex number? How this complex number come into meaning is, so if you write down here in this x-axis, x-axis is making cos of 0 degree, right? So in the reference, axis is 0 degree. Now if you go in opposite direction, that will be cos of 180 degree. And that will be minus 1. Okay, this is plus 1, cos of 0 degree. So this one in the horizontal direction, that will be multiplied by 1. And if you go in the opposite direction, that will be multiplied by minus 1, cos of 180 degree. Right? And if you go in the vertical, that is the sine part. Sine of theta. Okay, so if you go in the vertical, that will be sine direction. And this sine direction, we can consider this is making an angle of 90 degree. So this is the 90 degree. Okay, and this is part of the sine, and that will be, if this one is minus 1, and if I add them, square and add them, that will give me the total result, right? So if I add them 1, from where I can get 1? If I square this one and plus square this one, then I will get this one. So if you square, can you square? What is the value we are getting? So we are getting this one. So 1 is representing this. This one is representing half. And this one is representing, I have to make a meaning. So this one is representing 2 by 3. And then this resultant will make 1, right? So how I can get this one? It would be root 3 by 2 square plus 1 by 2 square. That will give me 3 by 4 plus 1 by 4 and that will give me 1, right? So that is from where we are getting the 1. Now, I can represent this one multiplying with 1. And this one, how I can represent this one? I should include that this is my direction. If I go in this direction, that will give me this value. So that I can consider that this is making an angle of 90 degree. And this one, we know that this will be let me just think. Okay, so if I make this one equal to positive 1, right? This one is the positive 1. And this one is the negative 1. That means if I want to consider, if I want to represent any vector in the opposite direction, that should be my minus 1, right? It has to be multiplied with minus. So if it is this direction is the positive 1, then opposite direction should be giving me minus 1. Okay, if I, in other words, let us consider that I have a vector 5 and making an angle of 0 degree. Okay, that means I can represent this one as 5 multiplied by positive 1. And this positive 1 is coming from cos of 0 degree. Okay, so I am multiplying. This term is coming, cos of 0 degree is multiplied here in terms of the value 1. Now, if my vector, so this vector is in this direction, right? Now, if I represent this one in the opposite direction, the same vector, what I have to do? I have to multiply with minus 1, and then this would be 5, right? Then it would be opposite direction. Are you getting? So positive 1 indicates in the horizontal direction to the right. Negative 1 arrow is on the opposite direction, and that is multiplied by minus 1, right? So what is the value? How I can represent this minus 1? Can I represent? Is there any way, mathematical way I can represent other than the cos? I don't want to include cos. I want to represent this negative value other than cos. Well, how I can do that? I equal to this is I, but this will be minus square root of I, right? This will be square root of I. So I equal to minus 1, but I need I. So that means I need to multiply with 2I. So I times I, that will give me minus 1. Okay? So this, if I consider this minus 1, if you take a look now, this graph, what is actually happening? My vector is here, and I am shifting 90 degree, then it is going this way, and going this way is another 90 degree. Do we find out any relation with I? So I need, first thing you have to get the idea is, if I want to represent a vector, horizontal vector in the opposite direction, then I can just multiply with minus 1. Do you get the idea? So one vector is in this direction, and I want to move it in the other direction. What I am doing? I am just multiplying minus 1 with that one. So 5, vector 5, positive 5 is in this direction. Now if I want to make it negative 5, I have to multiply minus 5 and then move it in this direction. Right? Now minus, whenever I am doing minus 1, then what I am doing? I am multiplying I twice. So first I am multiplying with I, it is shifting to the y direction. Then another I is shifting to the opposite y direction. So these minus I am trying to say that if I find out that opposite direction is making an angle of 180 degree. So that 180 degree is represented by I times I. 180 degree is represented by I times I, right? Do you get the idea? So now if I want to make only 90 degree phase shift, that will be I, right? Do you get the idea? No. So I have a vector in this direction. Okay, this is my vector 5. I want to move to the opposite direction. Then what I will do if I multiply with I, so if I multiply with this 5 to I, then I will move to here, 5I. And then if we multiply another times with I, then it will become 5I times I. That will be equal to minus 5, right? That's what I'm trying to say, that if you want to make the opposite, you have to multiply I twice. Now that means that opposite direction means 180 degree. If you multiply I twice, then 90 degree means you have to multiply it with one I. So that means we can represent mathematically vector V would be equal to V X plus I am shifting 1 times Vy. Okay, so this becomes my complex representation. Get the idea? No. Okay, we'll start from this one again. So all the meaning, all the representation has a meaning. How we have come
up with that representation? We might be just thinking that, okay, if I have a vector, I can represent this one in a complex number, but that complex number is actually coming from the shifting of the angle. Okay, so from here we will start again. So whenever I have represented this one, this becomes a complex representation, and this is nothing but a vector representation of any quantity. And why I have come up with this expression? Because I can add easily. Okay, so polar representation, we need it because whenever we want to do the multiplication division, polar is easier, but whenever we do the vector, the rectangular, then addition will be easier. Okay, so I think some idea you have got, some idea you have not yet got. So I will upload some exercise. You can do those exercises. And in the next class, I will start from here. We'll discuss again and try to explain this concept. All right. So did we conclude to Thursday morning or still coming? But some of you have the problem. You had the issue, right?
It's not a clash or something. It's just like uncomfortable for me.
Yeah.
Because it'll be like a big get, but I'll be fine.
You are fine.
Yeah.
So can you email me, all of you, that you are agree with this one? They're on Thursday morning. Then I will proceed to Thursday morning. You are not here, right? We have decided that on Friday at this time is my problem. At this time, if required, I will continue. But if it is possible, we can shift it to other time. That would be very good for me. Okay. So I have decided three options. We have decided one was Thursday morning, another Wednesday, and Friday morning. So other two were not everybody agree. Only option was Thursday morning from 8 to 10. 2 days shift. Okay. So you can discuss with them. So if you are happy, then email me. All of you email me. Everyone. So I need to show that everybody is happy. Is okay. So then we will continue. Otherwise, we can on Wednesday is fine, no problem from 10 to 12.
So we will then decide on that day. Okay?
So we have to change the timetable.
You just email me that we are happy to move it to Thursday morning. Yeah.
And where will that cost be?
That I need to take a look. When you are happy, when you are happy, then I will go back to timetable and find out a room. Yeah, that would be good. Then I can discuss on Monday.